Hello everyone, Mr. Travel here. We're going to go over 7.1, which is solving systems of equations. Okay, so as we go through, you guys have seen stuff like this from Algebra 2, but we're going to kind of expand upon it. So here I just want to make a little note. There's a few ways to solve these systems, which is substitution. Okay, we've got elimination. And then you can also do it by graphing. I just want to mention it. This is actually my least favorite, but you can definitely graph both equations and where do they intersect. Cool. This is definitely, and they're going to intersect at a point, at an XY point. Okay. Again, this is kind of the least efficient, and what if they don't land nicely on a coordinate point? What if your answer is like 2.23? It just doesn't work graphing, okay? But it is a possibility. Okay, so substitution, this is where you plug one equation into the other. Okay, solve for the variable, and it doesn't have to be x or y. It's one of it. It doesn't have to be that all the time. It depends on the problem. Okay, solve for that one variable and then plug back in to get the other variable. Okay, elimination. You can cancel out one variable. Okay, plug back in to solve for other variable. Cool. Okay, and just a quick reminder, remember whenever we're solving these systems, if it's just one equation, it's just where it hits the x-intercept. But if you've got multiple graphs like this, right, our solution is right here where they intersect each other. So wherever this point is, that is our solution, okay? So now, unless your teacher tells you you have to do a certain method, you could do any of the technically 3 methods, right? So we might have you do one of each at least on the test just to make sure that you know how to. But unless we say explicitly use substitution or elimination, you can use either one, okay? Typically one is easier than the other. In this case, if you look at number 1, we already know what y is equal to, right? And so what we could do is we can take what y is equal to and plug it in for the y in the previous equation, right? So we just plug it in. So we have 3x plus 2 times equals 4. And that times is this part, negative 2x plus 1. Cool, so all we did was substitute in that y, and now we're just going to solve it out. Right, so distribute in, so we've got 3x plus negative 4x plus 2 is equal to 4. Combine the x's, so we have negative x, subtract the 2 over, so we've got 2. So x is equal to negative 2. Okay, you don't have to do this, but what I like to do is I will start my answer already. So I know that x is negative 2, and now I just need to figure out the y. So now what you're going to do is take this value and plug it back into either of the 2 equations. Again, try to find which one's going to be easiest for you. Well, again, this guy's solved for y already, so that makes my life a little easier if I use that one. Okay. Technically, you could use the top one. It'll be a little bit more work, but it'll come out with the same answer. So you get, planning my answer already. So you get positive 4 plus 1, which in this case would be 5. So your answer for that guy would be negative 2, 5. Cool. Not too crazy. Now on number 2, if you notice, we don't have a y equals or an x equals. So what I'd like to do is, number one, make sure that all your x's, all your y's, and then all your constants are you're comparing apples to apples. So they're all on one side and the other ones are on the other side. Okay, so we have the x and y's on the left side and the constants on the right for both equations. Okay, so now you look to see, okay, if with the x's or the y's, can I multiply one or both of the equations to have them cancel out? Now you could do it for both. The first thing I see here is I always like the signs to be opposite. So I see a -3 and a +4. So if I notice, if I multiply this entire top equation by 4 and this entire bottom equation by 3, those y's will match each other but be opposite signs. So I multiply everybody out, so I get 8x minus 12y is equal to 36. And now distribute the 3 into everyone, so you have 9x plus 12y is equal to 24. Now some of you may have looked and gone, oh, I would have rather canceled out the x's. That's totally fine. That would work as well, right? And so now the nice thing are your y's cancel, and so I'm left with 17x is equal to, what's this, 60? And then from there, you're going to divide by 17. And just hope that this comes out to be a whole number. And unfortunately, it doesn't, right? So it comes out to be 60 over 17. And this is a great example of why graphing is not the greatest. So you want to see if you can reduce that guy. Unfortunately, we can't. So this is the x value, so I'm putting it in the x. So be careful, but I'm looking for the y. Okay, so that's my equation right there. Now I take this guy, or sorry, my coordinate point. I take this guy and I can plug it into either one. It doesn't really matter. I notice here this is a negative. I'm not too pumped about negatives, but these numbers are a little bit bigger. It doesn't really matter. So what I'm going to do is I'm going to do the bottom equation. So I'll do 3 times x plus 4y equals 8. All right, so again, this is not going to be the prettiest answer. So this is 3 times 60 would be 180 over 17 plus 4y equals 8. Now I'm going to subtract this by on both sides. So 180 over 17 minus 180 over 17. Now to get common denominators, I'm going to multiply that 8 top and bottom by 17. So I end up with 4y is equal to 136 over 17. That's what 8 is, minus 180 over 17. Now I'm going to bring it up here. Sorry, I'm running out of room. So 4y, now I'm going to simplify that. So 136 over 17 minus 180 over 17 would be negative 44 over 17. Over 17. There we go. And then now what I'm going to do is divide by 4. Again, this is a tricky, do you remember your fractions, those scary fractions? So y is equal to, this is 4 over 1, so I can skip this first fraction, flip the second fraction, and multiply. Now, if you notice, this is a little tricky. Yes, you can multiply straight across, but make sure you're always trying to cross reduce and stuff like that. So 4 goes into 44 11 times. So that makes my calculation a lot easier. So what I end up with, negative 11 over 17. Okay. Really hard to graph that one. But that's the coordinate point where those two lines intersect each other. Okay, cool. Now we have a couple special solutions. We'll solve these out real quick and then talk about them. Okay, So for this first one, again, the setup to me just looks really nice for elimination. So if I multiply, I see these opposite signs for the y. So I'm going to multiply the top by 2. And so I end up with 10x minus 4y is equal to 8. And then I didn't do anything to the bottom equation, so I'm going to keep it exactly the same. Now I add straight down. Oh, that guy goes away. Whoopsie boom. That goes away. So 0 is equal to 15. Okay. If you notice, both variables are gone. Okay. We'll pause on that guy and come back to it in just a second. Now with this other equation, I see that we already have x, so I'm going to plug that guy in. I'm going to use substitution. Minus 20y equals negative 40. Distribute in, so I end up with 20y minus 40 minus 20y equals negative 40. And now if you notice, I combine those two. That gives me 0. And then if I add this to the other side, that also gives me 0. So if you notice, with both of these guys, number 3 and number 4, both of the variables disappeared, right? But the answers look a little bit different. The green one has two numbers that aren't equal, and then the orange one that comes out to be 0 equals 0. Okay, and so on this guy, this special solution, this would be no solution. Okay, so think about two lines that would not intersect each other, and so that would be two parallel lines. Cool, so they never touch, so therefore we don't have a solution. Whereas this guy, this one is called, we do IMS, infinite many solutions. Okay, and so this one is, we have a line like this, and if I have something that always touches it, that means that it's right on top of it. Cool. So those are a couple special cases. One, either they never touch, or two, they always touch. Cool. Okay, one last problem. We'll talk about a little bit of chemistry here. So a chemist needs to mix 18% acid solution with a 45% acid solution to obtain 12 liters of a 36% acid solution. So on problems like these, my biggest recommendation is always, when you write the equation, they all have to be talking about the same thing. So if you're talking about money, they all have to be talking about money. If you're talking about amount, every single thing in the equation needs to be talking about amount. So if you look, we have two different ideas going on here, right? So we have an amount because it tells me that it's 12 liters. So this is one of the, this is one of the ideas is liters, and the other idea is percentage. So I know my total is going to be 12 liters. So I know that they don't tell me how much of the 18% or 45% acid I'm mixing in. So I get to make it up. So I'm going to say X is equal to the 18% solution, and Y is equal to the 45% solution. Again, this is not percentage, this is the amount. I should have put that amount of each of the 18. So one of my equations is just going to be X plus Y is equal to 12. So I need to get 12 liters with those two different types of solutions. Now I'm going to start talking about percent. Well, I have an 18% solution for X and a 45% solution for Y, and my total solution here, I'll do times 12 because that's the amount. That total final solution, we want it to be 36%. Okay, so again, the green one is all the amount, the orange one is all the percentage of each of the acids. Okay, and so now we just want to kind of simplify this out. You could do substitution, elimination, whichever one. This one kind of bodes well for, looks like elimination, but I don't really want to be multiplying one of them by 0.8 and 1/8 and all that kind of stuff. So what I did is I set y is equal to, and then I just subtracted the x, so 12 minus x. Okay, and so what I'm going to do is I'm going to substitute this y in for this y. You could totally do elimination if you wanted, or you could have solved for x first. It doesn't. There's a bunch of different options you could have. So this is 0.18x plus 0.45. Now the y is 12 minus x. And then now we can multiply these two guys together, and that gives you 4.32. That's just multiplying those two equations together. Okay. Once we've done this, yes, it's not super pretty numbers, but it's the same exact process. That is, so 0.45 times 12 is approximately 5.4. And then this is minus 0.45x, and we already have this guy here. So I'm going to subtract the 0.54, and then I'm going to put these two guys together. Okay, so if I do that, I end up with negative 0.27x is equal to negative 1.08. Okay? Which makes sense. Even though we've got negative, you'll see that I'm going to end up with two negatives, so it should turn into a positive, which makes sense. You don't want a negative amount of one solution. So this one says 4. Okay, so when we solve that out, that comes out to be a 4 right there. Now you could probably do this part in your head, but I'm just going to show you. I'm going to plug this one back into there, right? So we have 4 plus y is equal to 12. So my y is equal to 8. Okay, and so when we start doing some of these real life examples, your answers need to be specific and actually make sense. So if your boss said, how much of each solution do I need? And you said 4 and 8. 4 and 8 of what, right? So with these, we definitely want you to write it out. So we want 4 liters of, okay, it says of x. Well, x is 18. So, 4 liters of the 18% solution, okay, and 8 liters of the 45% solution. Okay, so make sure that you are specific and you actually tell us how much of each. Cool. I believe that's it. Okay. I'll see you guys soon for 7.2. Have a great day.